let's discuss about the past year question KMKJ 22-23, chapter 2. The question has stated that an electron of hydrogen atom is excited to the energy level n equals to 5 and then drop to a lower energy level, forming Paschen series. So state the energy level whereby the electron drop back. So it is excited to higher energy level, n is equals to 5, and then drop back to Paschen series. So we should know what is Paschen, and then there is 5 hydrogen spectrum, which is Lyman, Balmer, Paschen, Brackett, and P-Fun. It symbolized respectively is 1, 2, 3, 4, 5. So the Paschen is the third, so n is equals to, and then B, P, B, P, and then the second letter of the first BP is A. This one is the another letter. So L, BA, PA, BP. So the second question is calculate the energy of electron at the excited level. So what is the energy level at this state? N is equals to 5. So we can use the formula of En is equals to negative Ribble constant times 1 over n squared, and then sub into the n is equals to 5, so E5 negative Ribble constant time then 1 over 5 square. And press the calculator, we can get negative 8.72, and this is the answer. So the third question is calculate the energy emitted as a result of transition. So this one, it says that what is the energy when it drops from n equals to 5 to n is equals to 3. So we can use the formula of difference of energy, which is Ribble constant time initial minus final, and then sub into the formula. Initial is 5, this one is initial, and this one is final. Initial 5, this one 3. So this one is bigger than this one. The 5 is bigger than 3, so it will get a negative sign. Because this one is the energy emitted, so we can get negative 1.55 times 10 to the negative. We know that negative sign is equals to energy emitted, but we have to state it that energy emitted is equals to 1.55 times 10 to the negative 19 joule. This should be our final answer. So let's go into the question B. The question has stated that the highest energy electron of element Z occupied the following orbitals in third shell. Identify the orbitals and state the quantum number NLM for the orbitals above. So there is two questions in one question. One is identify and one is state. So we have to list down two answers. So first, we have to identify the orbitals. Since we know that S orbital we have a shape of spherical, P we have a shape of dumbbell, and for the D we have a clover, in which is like two dumbbell. So the orbitals we have now, this one is P, and we have stated that this is a third shell, so it's 3P, in which it lies on X and the Z. So it's 3px and 3pz. Now we have to state the quantum number. Basically it is NLMS. This, the N is state for the number of shell, L is state for the SPDF, whereas the M is state that the number of orbitals. Since we know that these have 3 shells now, and we have stated that this is the third shell, so we can get the NLM. It start with 3 because P SPDF 0, 1, 2, 3. So we can get this is 1, whereas the M we have 3 orbitals, which is -1, 0, and +1. So either we can get 0, -1, or we can get +1. These are 3 possible answers, whereas 2 answers are enough. Because in the question, we know that there is only 2 electrons in the highest energy. So now let's go into the question 2. Write the electronic configuration of element Z. So electronic configuration Z, we need to start from 1s and then continue all the way until the 3p. Since the 3p shell, the orbital of 3p we have two highest energy electrons. So the last orbital, we will fulfill it. We should fill it until 2 electrons, that's enough.